Hello, today I can reduce negative radicals by making the negative an I, breaking the radical down into perfect squares and non-perfect squares, and taking the square root of the perfect square. So this is a very similar lesson to something you did back in Algebra 1. You saw it a little bit in geometry last year, and now we're just going to add one little piece to it for Algebra 2. So first off, we need to be familiar with our perfect squares. So I wrote out the list of perfect squares here for you. Let's talk about where these numbers are coming from. So you end up with a perfect square when you're multiplying a number by itself. So 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. And I think you get the point. So a perfect square is the product when you multiply a number by itself, and the square root of that perfect square is what number multiplies by itself to get that value. So for example, the square root of 16 would be 4. The square root of 4 would be 2. The square root of 100 would be 10, because 10 times 10 is 100. So let's start with an Algebra 1 version of this. So this is not in the packet. This is just something that we did back in Algebra 1. In fact, let's start with 8th grade. If I have radical 9, well, since 9 is on my list, I just take the square root of it. The square root of 9 is 3. Now, let's say I had radical 8. Since 8 is not on my list, I need to find the largest perfect square that goes into it. So, it can't be bigger than 8, so 8 would fall here. Can I divide 8 by 4? Yes. So, I'm going to break it down into perfect squares and non-perfect squares. The largest number on that list that goes into 8 is 4, and 4 times 2 is 8. That's step 1. Step 2 is to take the square root of the perfect square. The square root of 4 is 2. The non-perfect square comes down, and 2 rad 2 is your answer. So you need to find the largest perfect square, the largest number on this list that goes into each value. Once you have that, you're breaking it down into that value and whatever multiplies by it to get the value you're looking for. In this case, 4 and 2 is 8. That's step 1. Step 2 is to take the square root of the perfect square. The square root of 4 is 2. Radical 32. Is 32 on my list? No. So I need to break it down into perfect squares and non-perfect squares. So what's the biggest number on this list that I can divide 32 by? Well, can I divide 32 by 25? No. Can I divide 32 by 16? Yes. So 16 and 2. Now let's say that you're not good with your times table and you don't know what goes into 32. There's a little trick in the calculator. So here's how the trick works. If I want the numbers that multiply to 32, I'm going to do 32 divided by x. This is very similar to what we did when we were factoring. It's the same thing, actually. We're just coming up with the factors. Then I go to my table. Now, what I'm looking for is a number on my perfect square list. So I'm looking for a number on this list that's in my y column, and I'm looking for the largest number on that list. So 32 is not on the list, 16 is, 16 and 2. So that's how you can use the calculator to help you. So that's step 1. Step 2, we take the square root of the perfect square. When I take the square root, the radical goes away. The non-perfect square comes down. That's your answer. So we're just going to add one new thing for Algebra 2 now, and that is taking the square root of a negative number. So what this is asking here is, what's the square root of negative 64? Well, we can't take the square root of a negative number, because a negative number times itself, a negative times a negative is a positive, and a positive number times itself is a positive. So, in the real number system, there is no answer to this. If you go to your calculator and you type in radical negative 64, you're going to get an error because there's no number multiplies by itself to give you a negative number. To deal with this, we use what we call the imaginary number system. And the imaginary number system is based on one simple fact. I is equal to radical negative 1. So what I can do is I can make negative 64 negative 1 times 64. Now I just said that I is equal to radical negative 1, so I can replace the radical negative 1 with an I. And now I dealt with the negative. I do the same thing that I just did back in Algebra 1. 60 square root of 64 is on my list. Radical 64 is 8. So my answer, I times 8, is 8i. Now, I don't need you doing this first step this way. When you're doing this, here's what I want to see moving forward. Basically, to get rid of a negative that's inside a radical, it comes outside and becomes an I. From there, again, you proceed however you would. Radical 64 is 8, so my answer is 8i. So to get rid of a negative inside of a radical, you bring it outside, you make it an I. Number 2, I see a negative inside a radical. My first step to get rid of that negative is to bring it outside, make it an I. So I'm going to rewrite it as I radical 50. Now, is 50 on my list? No. Let me see, let's see if I can just, if I can just have this list to refer to for each problem, it's going to make things a little bit easier. So 50 is not on my list. So I'm going to break it down into perfect squares and non-perfect squares. You can use your calculator trick if you need to. I want to find the largest number I can divide 50 by that's on this list. So I'm going to start here. Can I divide 50 by 49? No. 50 by 36? No. 50 by 25? Yes. So 25 is my perfect square, and 25 times 2 is 50. And that I just stays in front. Next step in reducing a radical, take the square root of the perfect square. The square root of 25 is 5, so it becomes 5i. And the non-perfect square comes down. And that's my answer. To get rid of the negative, bring it outside, make it an I. From there, it's the same thing you did back in Algebra 1 and geometry. You're going to break it down into perfect squares and non-perfect squares. It's helpful to have your perfect square list to refer to. And if you need to, you can use the calculator trick. So how I would use the calculator trick in this example is I would go to y equals, I would do 50 divided by x. I go to my table, and then 25 is the largest perfect square that goes in. Again, you have to have this list to refer to. All right. Number 3. To get rid of the negative inside the radical, I bring it out, I make it an I. 45 is not on my list, so I break it down into perfect squares and non-perfect squares. Why don't you take about, I'm going to give you about 10 seconds right now to try and find the largest perfect square that goes in. If you need more than 10 seconds, then pause it. Can I divide 45 by 36? No. Can I divide 45 by 25? No. Can I divide 45 by 16? No. Can I divide 45 by 9? Yes. So 9 and 5 multiply to 45. The I stays out front. Step 2 is to take the square root of the perfect square. Square root of 9 is 3. So it becomes 3i. rad 5. I want you to try number 4 on your own. Why don't you pause it? Okay, let's go over number 4. So first step, to get rid of the negative inside the radical, it becomes an I and goes outside. Now, let's get my list of perfect squares up there. 75 is not on my list, so I'm looking for the largest perfect square that goes in. 64 doesn't go into 75. 49 doesn't divide in. 36 doesn't divide in. 25 does. And again, if you don't have your times tables or can't figure that out, then you can go to y equals 75 divided by x, second graph, and you're looking in the y column. 75 is not on the list, 37.5 is not on the list, 25 is. So I break it down into my perfect squares and my non-perfect squares. 25 and 3. The square root of 25 is 5i, and the rad 3 comes down. So we're going to skip ahead to the back of the sheet. It's basically just an application of this. So we're going to skip ahead to number 9. And this is going to be just an application of what we just did. And we're going to basically use the isolate and radical method to solve quadratic equations, which we can use whenever we don't have a b value, whenever we don't have an x value. If it's just x squared and a constant like we have here, we can use the isolate and square root method. So my first step would be to isolate. I would subtract 4 from both sides, and I get x squared equals -4. Now, you guys have learned algebra, and you know to get rid of a square, I do the square root. And whenever you do the square root, there's going to be 2 answers, one positive, one negative. So I'm going to end up with x equals plus or minus radical -4. So whenever you take a square root of something, there's always 2 answers, one positive, one negative. Now I just need to reduce my radical. So to bring the negative outside, it becomes an I. 4 is on my list, so I don't have to break it down into perfect squares and non-perfect squares. The square root of 4 is 2. So my answer is plus or minus 2i. Again, whenever you take the square root of something, you take the square root, you're going to end up with plus or minus because there's 2 values that multiply to that value. One positive, one negative. Number 10, I want to solve for x, so I'm going to isolate and square root. I'm going to subtract 16 from both sides. I get x squared equals -16. And then I take the square root to get rid of the squared. When you take the square root, we put plus or minus, radical -16. Now I need to deal with the negative radical. So again, first step in dealing with a negative radical, bring the negative outside, make it an I. Now, 16, is it on my list? Yes, so I don't have to do the perfect squares and non-perfect squares. Square root of 16 is 4, so my answer is plus or minus 4. Let's skip ahead to number 13. I want to solve for x, so I'm going to isolate by subtracting 24 from both sides. And then to get rid of the squared, I do the square root. When you take the square root, it's plus or minus. Now, to get rid of that negative inside the radical, it comes outside and becomes an I. Now, 24 is not on my list, so I need to break it down into my perfect squares and non-perfect squares. Can I divide 24 by 16? No. By 9? No. By 4? Yes. 4 and 6 is 24. Everything else comes down. I take the square root of the perfect square. Radical 4 is 2. So my answer is plus or minus 2i rad 6. So it's basically the same thing we did on the front, but now we are using that procedure to solve a quadratic equation, to solve an x squared equation by isolate and square root. So I want you to try number 14 on your own right now. I'm going to ask you to pause it, try it on your own, and then unpause it. Okay, at this point you should have tried number 14 on your own. So to solve for x squared, I'm going to start by subtracting 90 from both sides. That gives me x squared equals negative 90. Then to get rid of the squared, I take the square root of both sides. When I take the square root, it's plus or minus. To get rid of the negative inside the radical, it becomes an I and goes outside. Now 90 is not on my list. So I need to find the largest perfect square that goes into it. Can I divide 90 by 81? No. 90 by 64? No. 90 by 49? No. 90 by 36? No. 90 by 25? No. 90 by 16? No. 90 by 9? Yes. 9 and 10. The perfect square always needs to go first when you're reducing a radical. Now we take the square root of our perfect square. The square root of 9 is 3. So it becomes plus or minus 3i rad 10. So whenever you're reducing a negative radical, the negative comes outside. Just do a different color here. Whenever you're reducing a negative radical, the negative comes outside, becomes an I. From there, it's the same thing you've been doing back since Algebra 1. Break it down into perfect squares and non-perfect squares. Use this list because it must be a number on this list that goes first. If you're really bad with your multiplication, use your calculator trick. Y equals the number that you're reducing divided by x. And then when you go to your table, you're looking in the y1 column for a number that's on your perfect square list, the largest number that's on your perfect square list. Once you separate them into perfect squares and non-perfect squares, you take the square root of the perfect square. When you do that, the radical goes away. If there's an I outside, that I just goes with that value, and the non-perfect square comes down. Your classwork/homework is to finish imaginary numbers. And as always, if you need any help, watch this video again, ask me for help on reminds, tutorial, whatever you got to do. Have a great day.